All right, this is a force of 600 pounds is needed to pull a car up a ramp which has an inclination of 15 degrees. Assuming no friction is involved, find the weight of the car in pounds, around 1/10 of a pound if necessary. Okay, so the key idea here, let's just draw my ramp, okay, and here's my horizontal. Okay, so some people who take physics might have a better understanding of this, but if not, it's okay. So we have a car. Okay. Now, when it says a force of 600 pounds is needed to pull the car up this ramp, another way of saying that is that like the force in this direction, so the direction kind of against the ramp, is 600 pounds. Now, so there's that force, and then there's the force of the car being pushed against the ramp itself, and that'll always be at like a 90-degree angle to the ramp. So in short, what we have is we have the car's weights being distributed in two directions. One direction is right here against the ramp, again at a right angle. And then the other one is this 600 pounds going in this direction. Okay, so that's 600 pounds. We don't know, I don't know how many, the weight against the ramp here. But the thing is, these two vectors have to add up to the vectors, the car's weight. And so the car's weight, I'll just, represent it as vector W. That's going to be straight downwards, okay? And it should be, 0 something, 0 whatever the car's weight is. Actually, I guess it should be 0 negative W if it's facing downwards. So what we're going to do, or so what I typically do here is, unlike in a physics class, in a math class, what you do, you try to, I impose like a little coordinate system here that'll help me add the vectors. Okay, so like what I mean by that is I'm going to let's call this here vector, I'll just call this vector A. Okay, and I'll call this here vector R for the ramp. Okay, and so like what I know is that vector A plus vector R has to add up to the weight of the car. Okay, like it's the car's weight's being kind of evenly distributed into two directions, but those have to add up to vector W. So let's draw like a little XY plane here. All right, and so this my vector A over here. Okay, that's going, so it's going to go in the complete opposite direction. I'm going to just sketch my x-axis here, x and y-axis here as well. Okay, so like that's going to be going in the complete opposite direction of the ramp. So it's going to look like this, where that's 15 degrees. Okay, and this is vector A, and its magnitude is 600 pounds. Okay, and then the ramp, which is here, I'm going to kind of move it. I'm going to move it to be at the origin for a moment. Okay, that's going to look like that. Well, so it'll look like this. Okay, but if we're going to add it to vector A, what we need to do is we need to bring it down here. So if I bring it down here and add it to vector A, okay, my length is a little bit off, but that's okay. I'm trying to fudge it a little bit. Okay, I need to extend it a little bit. Okay, we're trying to show. Okay, I'm trying to show that it would equal the vector W. Okay, so this is vector W. Okay, which again we know has these components. Okay, this is vector R, and so now my diagram is really depicting a plus R, and it has to equal W. Okay, so let's let's kind of start getting the details here. Let's write the, whatever vector A is in its component form. So vector A is a magnitude of 600, and the direction angle is cosine, so the direction angle is 180 plus 15 degrees, so it would be 600 cosine of 195 degrees, and then 600 sine 195 degrees. Okay, vector R. Vector R we can actually figure out. We can't figure out its magnitude. We don't know that. So I'll just leave that as its magnitude. But its direction angle we actually can figure out. So the reason is, like, go back up here. Remember, it's making a 90-degree angle with the ramp. So if it makes a 90-degree angle here, I have to fudge this line a little bit, and that's 15 degrees. This angle here must be 75 degrees, or negative 75 degrees, for it to add to create a 90-degree angle. So we're going to call that cosine, we can say negative 75 degrees. Okay, and now when I add these vectors, I have to get vector W, which we see down here, okay, is 0, negative W. So I add them, and I get 600 cosine of 195 degrees plus the magnitude of R cosine of negative 75 degrees. Okay, I'm going to move that a little bit just so I can... Okay, and then when I add these, I get 600 sine of 195 degrees plus the magnitude of R sine of negative 75 degrees. All right, and like we know that has to equal W, so the components need to equal. So this has to be, right, this all has to equal 0. That's important because that's going to let me find R, the magnitude of R. And then once I know the magnitude of R, I can put it in here, and now that'll give me the weight of the car because that's the only unknown there. So I have that 600, so this implies that 600 cosine of 195 degrees plus the magnitude of R times cosine of negative 75 degrees has to be 0, or in other words, if we subtract this from both sides and then divide by cosine of negative 75 degrees, what we have here is that the magnitude of R is negative 600 cosine of 195 degrees divided by cosine of negative 75 degrees. So we'll go compute that. Okay, so it'll be in degrees, and we had negative 600 cosine of 195, and then we're dividing that by cosine of negative 75. Okay, so I'm going to call that something because I'm about to use it again. So I'm going to give that a letter here. I'm going to assign it to a variable. So that's R. And now if I go back to my, if I go back here, all right, so we've like stored this, it's on the other screen. But now I'm just going to plug it in here. Okay, so negative W is equal to whatever 600 sine of 195 degrees plus the thing we just found. Okay, that's stored in the other screen. Okay, so I'm just going to type all this out, and we'll be done. Okay, so 600 sine 195 plus the thing I'm calling R times the sine of negative 75. Okay, that's equal to negative, remember that's equal, so it's negative 2318.2 and that's negative W. So that means W, again, being the weight of the car, is 2318.2 pounds.